Okay, the topic of the day here is equations with two variables. And first of all, we're going to want to define an equation with two variables. And these are examples here of equations with two variables. Notice the top one has an x and a y, two variables. Here, an x and a y. Here, an x and a y. Right? That's all an equation with two variables is. However, finding the solution for an equation with two variables works a little bit differently than finding the solution for an equation with one variable. With one variable, we got an answer such as x equals a certain number. With a two variable equation, we're going to get two parts of an answer. We are going to get an answer for x and an answer for y that goes with the answer for x. So it's going to have two parts to it. So the solution for an equation with two variables is a pair of numbers, a certain x value with a certain y value. Here's the thing to understand. With an equation with two variables in it, there are infinitely many answers all the time. It's just that a certain x goes with a certain y. So it's not, for example, all real numbers or all solutions. It's just that the number of solutions is infinite. But there are specific solutions. So the solution for an equation with two variables is called an ordered pair, and it is written like this, in parentheses, with the two numbers inside and a comma between. What goes right here is the x value. What goes right here is the y value. If you have a's and b's instead of x and y, or g and h instead of x and y, they go in alphabetical order in the parentheses. All right, so here the value of x goes in the first position, the value of y goes in the second position. And what we're going to do now is actually go through an example of solving an equation with two variables. Now remember, this has infinitely many solutions, so we can figure out many solutions. We're just not going to do that. It would take forever. So what we're going to do in this first example is solve the equation 3x plus 2y equals 8 if the domain of x is -2, 0, and 1. What this means when we say domain of x just means the x values. So in other words, these are going to be the values for x that we're going to use, and we're going to figure out what y's go with them. Every value of x has a y that goes with it. We just need to figure out what it is. So I can figure out infinitely many points because there's infinitely many x's, but there's only one y that goes with each x. So first of all, the way that this works, my points would be set up like this in ordered pairs. These are my x values, so I put the -2, the 0, and the 1 in the x position in the ordered pairs. The way that I figure out the y is to plug this value in for x. So if x is -2, it's going to look like this. 3 times -2 plus 2y equals 8. Simplify and I get -6 plus 2y equals 8. Add 6 to both sides. I have 2y equals 14. Divide both sides by 2 and I have y equals 7. So the y value of 7 goes with the x value of -2. All right, let's do another one. This time I'm going to use an x value of 0 So I'm going to plug 0 in for x and figure out what y goes with it. So I have 3 times 0 plus 2y equals 8. 3 times 0 is just 0, so all I have is 2y equals 8. Divide both sides by 2, and I'm going to get y equals 4. So with my x value of 0, I have a y value of 4. Let me do the next one. Here I have an x value of 1. So I have 3 times 1 plus 2y equals 8, which gives me 3 plus 2y equals 8. Subtract 3 from both sides, and I have 2y equals 5. Divide both sides by 2, and I have y equals 5 over 2. So my point is 1, 5 over 2. Now, I can actually do the same things if I know the y value. If I know the y value and I want to figure out what x value goes with it, I'm simply going to plug that y value right here in the equation and figure out or calculate using algebra what the x value is that goes with it. So I can work starting with the x value or the y value. All right, the next example, we're going to do something a little bit different. I have 2 points here, and it says, are these 2 points solutions for the equation 5x plus y equals 6? The way that we figure this out, this is an x value, this is a y value. I'm going to plug in the x and y values into the equation and see if both sides are the same. If both sides are the same, it is a solution. If the two sides are different, it is not a solution. So I'm going to start with the 2 and the negative 4. This is an x value. This is a y value. So I have 5 times 2 plus negative 4 equals 6. This is 10 plus negative 4 equals 6. 10 plus negative 4 is 6 equals 6. Since both sides are the same, yes, this is a solution for the equation. Next, I'm going to do 0 and 6. Remember, 0 is the x value, 6 is the y value. So I have 5 times 0 plus 6 equals 6, which gives me 5 times 0 is 0. So I just have 6 equals 6. And yes, this would be a solution. Let's try another one. We'll do it off to the side. How about 1 and 3? So we'll plug in 1 for our x value, 3 for our y value, and check this. So I've got 5 times 1 plus 3 equals 6. This gives me 5 plus 3 equals 6, which is 8 equals 6. Since both sides are different numbers, this is not a solution. So no, it is not a solution. Let's go to the next page. What we're going to talk about here is linear equations with 2 variables. And we're going to talk about how they might look when we see them. So first of all, a linear equation with 2 variables, hereafter called a linear equation, is an equation that can be written as ax plus by equals c. And when we say that, all we mean is that the a, b, and c are numbers. All right? That's it. There's an x, there's a y. The power of x is 1, so you don't see it. The power of y is 1, so you don't see it. If the x or the y has an exponent other than 1, it may be an equation in 2 variables, but it is not linear. Linear has a power of 1 here and a power of 1 here. So if I had something like this, This is not linear because the powers on x and y are not 1. So this would be not linear. It is still an equation with two variables, it's just not linear. So an equation that is linear might look like this. This is linear. The power of x is 1, the power of y is 1. Now, we can write our x term, our y term, and our constant term in a variety of orders, and it is still a linear equation with two variables. So here's what we have at the bottom. We've got two different forms. We're going to go through both of them. And remember, linear means a straight line. So at the bottom of the page, we have these two formats for writing linear equations. The first one is called standard form. When I ask you to write linear equations in the future, I'm going to specify the form, which is why you need to know the form. So standard form, which your book also calls general form, looks like this. ax plus by equals c. The x term is first, then the y term, then an equal sign, then the constant term. And here's what you also have to have. A, B, and C must be integers. No fractions, no decimals. We have ways that we can get rid of fractions and decimals, and we're going to use those ways. And A, the first term here, must be positive. So it cannot be negative. If it is, we can change this so it's not, and I'll show you how to do that. So an example of an equation in standard form is 3x minus 2y equals 4. We have a 3, a 2, and a 4, all integers, no fractions, no decimals. And the 3, the first one, is positive. Doesn't matter what the rest are as long as this one's positive. Secondly, we have slope-intercept form. Slope-intercept form looks a little different. In this case, we have y equals mx plus b. So here, the coefficient of y, or the number in front of it, has to be positive 1. It has to be positive 1. But m and b can be anything, and they can be fractions, and they can be decimals. So here's an example. Y, all by itself, equals negative 3/2 x minus 2. See, we can have a fraction. This can be negative. This can be negative. Only this must be positive 1. All right? So our next task is we're going to practice writing equations in standard form and slope-intercept form. So first of all, here's an equation. It happens to be written in slope-intercept form. We need to write it in standard form. So first of all, our x term needs to be on the other side. And the way that we get it over there is to subtract it. So subtract 4x from both sides. And I have negative 4x plus y equals 1. And this is something we did in section 1.7 when we were solving equations. Now, here's the issue. I have no fractions and no decimals, which is good, but this needs to be positive, and it's not. The way I'm going to fix that is divide everything by negative 1. So divide this by negative 1, this by negative 1, this by negative 1. Everything gets divided by negative 1. And now I have positive 4x minus y equals negative 1. And that is standard form. Let's go to the next one. This second one is also written here in slope-intercept form. We need to write it in standard form. A couple of issues. We've got x on the wrong side, and we have a fraction. We're not going to be able to have fractions in standard form, so we'll need to get rid of them. The way that we go about doing that is we're going to multiply by the denominator. But I have a certain order I like to do this, and of course you can do this in a variety of orders, but the first thing I like to do is get my x term on the right side, or I guess I should say the correct side, which is the left side. And I'm going to do that by adding 3/2 x to both sides. And now I have 3/2 x plus y equals -2. The issue I have here is I cannot have a fraction. So I'm going to multiply everything by 2 to get rid of my fraction. I'm going to multiply my y by 2, and the -2 is going to get multiplied by 2. When I do that, these 2's cancel so that I no longer have a fraction, and I have 3x plus 2y equals -4. So I have no fractions or decimals, and I have a positive number in the front. All right, let's try this in reverse. In the next example, we're rewriting the equations in slope-intercept form. So we want them in the form y equals mx plus b. So if I look here, the first thing, I have x on the wrong side. I'm going to move it to the other side by subtracting x on both sides. When I do that, I have 5y equals -x plus 30. Now, the reason I put the -x first is because the form is y equals mx plus b. The x term comes before the constant. Now, the second issue I have here is I have to have just a 1 in front of my y, and I have a 5. The way I'm going to get rid of that is divide everything by 5. But it's okay that I'm going to create some fractions, because fractions are okay on the right-hand side of this equation. So here the 5's cancel, and I have y equals. This you can write as -x over 5 or -1/5 x. Either way, 30 divided by 5 is 6, so plus 6. And remember, it's okay to have fractions or decimals on the right-hand side of slope-intercept form. All right, the next one. I'm going to start by moving my x term. It needs to be on the other side. So subtract 3x. Now I have the 3x's cancel on the left, and I have -2y equals -3x plus 4. I need to have a positive 1 in front of my y, so what I'm going to do is divide everything by -2. The -2's cancel here and gives me y by itself, which I need. Here, my negatives cancel, and this gives me 3/2 x. Here, a positive and a negative means a minus sign. 4 divided by 2 is 2.